The third criterion that we're going to be discussing in this video is the Hurwicz Criterion. This criterion is also known as the optimistic-pessimistic criterion. Optimistic in this context means maximizing return on investment. You see, this criterion allows the decision maker to take into consideration both the best possible outcome and the worst possible outcome. To do this, in order to use this criterion, the decision maker chooses a coefficient of pessimism known as alpha. That is the coefficient of the worst possible outcome. And this coefficient ranges from is a decimal number that ranges from 0 to 1, and this number determines the emphasis on the worst possible outcome. And after getting the coefficient of pessimism, because Hurwicz criterion combine both the maximum criterion and the maximal criterion together, we also need the coefficient of optimism. To get the coefficient of optimism from the coefficient of pessimism, that is, beta is equals to 1 minus alpha, where beta is the coefficient of optimism, while alpha is the coefficient of pessimism. Beta is also known as the coefficient for the best possible outcome, while alpha is also known as the coefficient for the worst possible outcome. Now we have question number 3. Supposing a farmer who has 3 possible maize varieties to choose from is facing 4 possible states of nature. The payoff matrix shown the status of each varieties and nature is given, where V and N represent the available varieties and nature of the weather respectively. Determine the best strategy for the farmer using the Hurwicz criterion, given that the coefficient of pessimism, which is the alpha, is equals to 0.7.
To determine the best strategy for the farmer using the Hurwicz criterion, let's start by calculating the coefficient of optimism, which is beta. Don't forget that beta is equals to 1 minus alpha, where alpha is the coefficient of pessimism. So don't forget that alpha that they gave us in the question is 0.7. So I'm going to have 1 minus 0.7. So beta is equals to 0.3. So the coefficient of optimism is 0.3. After calculating the coefficient of optimism, I want to give you a formula. You can, since Hurwicz criterion combine both word maximum criterion and the maximized criterion together, that is the reason why I have rho maximum here and the rho minimum here. Now let us start by listing the rho maximum first. So I'm going to have R max, rho maximum, and I'm going to have another one, rho minimum. Now for variety 1, the rho maximum is 70. So I'm going to have 70 in this place. For variety 2, the rho maximum is 80. So for variety 3, the rho maximum is 100. So that is 70, 80, 100. Sorry. Now let us list the rho minimum. The rho minimum for variety 1 is 16. So I'm going to have 16 in this place. The rho minimum for variety 2 is 24. The rho minimum for variety 3 is 10. So I have calculated the rho maximum and rho minimum. The next step is to substitute the rho maximum and the rho minimum and the alpha and beta into this formula. Then the highest value among these varieties is the will be the correct answer, will be the best strategy for the farmer according to the Hurwicz criterion. Now let's start. For variety 1, I'm going to have x1 is equals to, don't forget that alpha is 0.7, so I'm going to have 0.7 multiplied by the rho maximum for variety 1 is 70. So 70 plus what is beta? Beta is 0.3 as we have already calculated in this place. So I'm going to have 0.3 into bracket the rho minimum. The rho minimum for variety 1 is 16. So I'm going to have multiplied by 16. So for variety 1, the strategy for variety 1 is 0.7 multiplied by 70. That is 49 plus 0.3 multiplied by 16. 16, that is 4.8. So the strategy for variety 1 is equals to 49 plus 4.8, that is 53.8, which is approximately is equals to 54. So the strategy for variety 1 is 54. Let's put it here. Now let's calculate the variety 2. The strategy for variety 2 is equals to alpha. Don't forget that alpha is 0.7. So I'm going to have 0.7 multiplied by the rho maximum. The rho maximum for variety 2 is 80. So 0.7 multiplied by 80 plus beta. beta is 0.3, so I'm going to have 0.3 multiplied by the row minimum is 24, so I'm going to have multiplied by 24 in this place. So S2 is equals to 0.7 multiplied by 80, that is 56 plus 0.3 multiplied by 24, that is 7.2. So 56 plus 7.2, this second variety 2 is 56.7.2, that is 63.2, which is approximately is equals to 63. So for variety 2 we are going to have 63. Now let us proceed to calculate the strategy for variety 3. I'm going to have S3 is equals to alpha, which is 0.7 into bracket. The row maximum for variety 3 is 100, so 0.7 multiplied by 100 plus beta is 0.3 into bracket. The row minimum for variety 3 is 10, so into bracket 10. So S3 is equals to 0.7 multiplied by 100, that is 70 plus 0.3 multiplied by 10, that is 3. So the strategy for variety 3 is 70 plus 3, that is 73. So I'm going to have 73 in this place. Now we have calculated the strategy for variety 1, variety 2, and variety 3. The best of this strategy is the highest among this strategy. So, and the highest strategy among this strategy is 73. So, we are going to choose 73 according to Hurwicz criterion of decision